Hello, I'm Pierre Boulet. I'm a professor of computer science at the University of Lille, and I'm vice president for digital transformation at that university. And it's in that subject that I will present our work in Europe about making an infrastructure to allow several use cases, and especially the use case that is interesting for universities is giving students a new kind of diploma, a verified diploma, where they can show their diploma with confidence that it is a real diploma awarded by a real university and that is not, has not been tampered with. The goal is to fight against fraud to the diploma. So I will use the slides of the European Blockchain Partnership. So I will share my screen now. Share. Okay, you should see it. Presenting the EBSI architecture, which is this blockchain network based on open standards and a transparent governance model, where one of the use cases is diploma sharing. So the main question about blockchain is how to build trust. Blockchain is all about trust. So a few words in introduction to what a blockchain is. It is a distributed ledger to decentralize permanent digital records or transactions. So ledger is something well known since antique times, where you write. It's a write only. You write once and it's not modified. So you keep a record of transactions. These transactions can be monetary or else something else, like giving a university awarding a diploma to some young diplomee, and this diplomee showing this diploma to a future employer. A distributed ledger is a ledger where the entries are stored across a node in a peer-to-peer way, making it tamper resistant. Every operator has a copy of the node, of the ledger itself. And if you want to modify something which has been written on the ledger, you need to acquire the control of a large proportion of the operators of the system. This proportion depends on the concrete protocol. Between 1/3 and half of the operators is usually needed to be able to modify what is written on the ledger. So if you have a large enough and diverse with diverse interest operators, that technology, blockchain, makes it tamper resistant. Basically, this kind of ledgers use cryptography to create trust between these different systems, so that if you modify one record, it is easy to detect the modifications, because the blocks are chained, and if you modify a block, this modification should be, in order to be hidden, it should be propagated to all the following blocks. And this is complicated to do, and not only complicated, but nearly impossible if you don't control a large enough proportion of the operators of the infrastructure. How to do that is using a shared consensus mechanism, a shared consensus protocol. There are the first one, which was used in the first largely well-known blockchain, is the proof of work, which is known, which has been introduced in such a system by Bitcoin, and is used also for Ethereum. This protocol means that to modify, you need to control a large enough proportion of computers doing some work, and so it's too difficult to modify the ledger if you don't have enough computing power, and it becomes economically infeasible when the number of protocol operators, infrastructure operators is large enough. So this is the case for public blockchains like Bitcoin or Ethereum, and it has tested. It has succeeded for the last 10 years, so it has sustained the test of time. This protocol is now very strong, and people have trust in it. So that's why the course of Bitcoin is growing right now. It's one of the reasons. But problem of proof of work is that it costs a lot of energy to run, just to run the protocol, the consensus protocol. And so we have alternatives like the proof of stake, where instead of controlling enough computing power, you control enough, a large enough amount of money, of the currency of the blockchain. Like you invest in a company by investing your money, and this money is stored somewhere. You cannot use it. It is given to the company, and you have you win by this staking of some money in a company, some right to participate to the governance of the company. Is it exactly the same thing in a proof of stake consensus-based blockchain? These are used usually in permissionless or public blockchains, where you don't need any special authorization to write on the blockchain. You need to gain the consensus of all the operators of the infrastructure, but you don't need a special authentication. On the contrary, you have a private or permissioned blockchain, where you need to be approved by some governance to be able to write on the ledger. And this is another kind of consensus algorithms, which is usually called proof of authority. And these algorithms usually come from the distributed algorithms world, with BFT, so Byzantine fault tolerance, and derived from Byzantine fault tolerance, practical Byzantine fault tolerance algorithm, usually. So EBSI is this kind of blockchain, which is a permission blockchain, where you need to be approved to write on the blockchain. So the question is, who is authorized to write on the blockchain? And we will come to that a little bit later. It depends on the use cases. So when transactions are added to the blocks are validated by the different operators, by the consensus operator, and every node thus has an identical copy of the blockchain, making it resistant to failing nodes. So EBSI, what does it mean, and what is the governance behind this project? The governance is a partnership, a special kind of partnership, the European Blockchain Partnership, which is a group which has been signed by a group of 29 countries, the 27 from the European Union, plus Norway and Liechtenstein, and the European Commission. So it's not a European Commission-led project, it's led by the different member states. And the goal is to promote blockchain technologies and to build an infrastructure to enable public cross-border digital services. So there is really the goal of building an infrastructure and getting the money to do that. And this money is it comes from the European Union through answers to project. Yeah, basically. So the goal of EBSI is to make a distributed blockchain ecosystem based on open standards for sovereignty. So for transparency is very interesting, very needed for trust. So open standards is a way to get this transparency and the trust. and also a transparent government model. So the 5 key principles are public good, governance, harmonization, open source, and conformity to the European regulatory framework. So public good, EBSI is not will not be available for private to private applications. The applications that will be run on the EBSI blockchain are dedicated to public services, whether they are national or transborder, transnational services. And the first use cases are international, at least European use cases. Governance. The governance of EBSI answers the trust problem by selecting the operators. The operators are only public bodies appointed by their government, and to enable the immutability, you need to have a really decentralized operations. So you need to harmonize the number of operators per member state. And there are rules which are written stating how many operating nodes should be in a given state. You cannot put 100 nodes in one country and one in the neighboring country. The largest number will control the consensus and thus the data written on the ledger. So the governance states that there is a balance between all the participating states. And this is checked regularly so that rules exist on how to deal with a country wanting more or less nodes, how to approve a node operator, and so on. This has been discussed and is written in the rules of the European Blockchain Partnership. Harmonization, the idea is to have, at least technically, you need to run the same algorithm with using the same data, but the code, we try to have the same code for everybody, so that you have only one code base to deal with and to check, to maintain in operation. So there is a strong technical lead by the European Commission on this. At least the 29 countries have mandated the European Commission to build the software, and then they operate this software by their public bodies themselves. Open source, so priority to open source software for security. You need transparency for security and for trust. So all the code in EBSI is open source right now, and it should stay like that. And as we are in Europe, we have strong values which are not the same in all the regions in the world, and we have strong laws, regulations to enforce these values, like the EIDAS for digital signature and the digital identity, the GDPR for the protection of personal data. We have also some standards, like in the case of diplomas, we have Europass. So EBSI is working with the other within this regulatory framework to respect the existing regulations, to make them evolve so that the use cases are possible and respect the great values of the European Union. So there is not only technical discussions, there are also law discussions about the impact on the law and on the social good and on the impact on the whole ecosystem of our country. So not a little bit more deep in the technicality of this architecture. So what is needed on the left first for a transaction? you need to initiate the transaction, then to create the transaction, and to validate and store the transaction. This is the consensus algorithm. A typical architecture to support such a transaction flow is the transactions are initiated in business and applications. Then you can have corporate services and principles to check and create the transaction, respecting some dedicated formats. And then you have the chain and the storage, where you have smart contracts, which come into play to ensure that people are correctly identified, the business rules are respected, and so on. And then the consensus stores the information in the infrastructure. The EBSI architecture, so business and applications are not part of EBSI. These are made by public bodies which want to build some use cases. So they are use cases specific and can be developed by any public body in Europe wanting to use EBSI. Then you have core services. These core services are a set of standardized APIs, application programming interfaces, to enable third parties like the business and applications to use the services of EBSI. And we will go a little bit later in the details of which services does EBSI provide. And these core services enforce the values of EBSI, so public goods, governance, the technology harmonization, open source, and compliance to the legal framework in Europe. And then you have the technical infrastructure itself with blockchains, storage systems, smart contracts, and so on, and stored in the infrastructure, which is operated together with the 29 member states. So a little bit in detail, what kind of flow, basic flow using EBSI? First, you initiate the transaction through a business application. Then you need to create the transaction, and this takes several steps. First, authorization via an access token. You need to be approved to write on the system. Then you prepare the transaction itself, the file representing the transaction. Then you sign the proposed transaction by the user. This verification, this signature, and the format of the transaction is verified by the API, and then you can validate and store the transaction. So this is validated, decentralized validation. No, sorry. First, a local validation by a local node. Then the proposition of this transaction inside a block in the blockchain. And then the consensus algorithm checks the different proposed block and accepts or not by the consensus protocol the different blocks. So there also a verification, a validation of the transaction by the other nodes. And once the consensus has approved the proposed block, it is stored in the ledger. So it's a typical, sorry, I come back there. It's a typical workflow with the addition of some authorization and verification of the signature. So an example here. So the business applications are the interfaces to the citizens and the legal entities. So they can use typically what is called wallets. And you have heard that the European Commissioner, as Pierre Boulet, has proposed that each European citizen will be able to have a wallet where they can store their digital identity and digital identity attributes. And these wallets will enable the interaction with For example, the EBSI infrastructure. So the wallets are not part of the EBSI, but EBSI provides APIs so that wallets can use the infrastructure. Core services are exposed via APIs for performing the different ledger, building the ledger transactions. And there is a smart contract which checks all the required signatures. Then another smart contract enables the execution of some transactions if you need some execution. And they are used also to manage the trusted registries. I've not talked about these trusted registries yet, but we'll have more detail about them later. It's, for example, where you can check that a university is the key that is signed on a diploma is the key of a university, and this university is allowed by its country to emit diplomas. And so this is this is checked using trusted registry in the infrastructure of EBSI. And then you have the ledger and the blockchain itself that stores the information. So the core services, which are these services? First, you have identity services. So you have a verifiable presentation API or library, which allow you to show some information which has been recorded on the blockchain to a third party. You have a verifiable credential API and library to enable to emit and to receive and to and to store the different verifiable credentials. All these use W3C standards, the verifiable credential standard, the VC standard, open standard. You have an identity hub API allow to plug, for example, a national identity, a legal identity in one country inside EBSI, so that business application using EBSI can check the legal identity of people or companies. You have also APIs and libraries dealing about DID, so decentralized identities, which is also a W3C standard and which supports all these identity management. Trusted registries, I've talked about them. So you have several registries which are handled by humans in some way. It's in the interface between the legal and real world and the electronic signatures of these entities. So you have the applications which are registered, the issuers, like a university issuing a diploma, the smart contracts registries also in such a registry, the schemas of describing the different formats of the applications, and the IAM registry. I don't remember what this one is, sorry. So you have libraries for wallets, allowing people to build wallets. So signing blockchain transactions. We provide reference implementation, and you have key management inside the wallet. You have some security management APIs with the reverse proxy. You have some integration APIs, which hide the technical choices which are in the ledgers themselves. So timestamping, storage, accessing the ledger itself, reading, authorization, notification, revocation. And so we can change or add different blockchains, blockchain or protocols. The EBSI is multi-protocols, and these integration APIs hide the details of each of these protocols. We have different protocols for to ensure that the infrastructure provides the best solution at a given moment, and to enable different capabilities of these blockchains for different applications. And several tools to integrate all these capabilities inside application. I should go a little bit faster. So the infrastructure uses smart contracts to check that everything is working as intended. A lot of them to handle the registries, to deal with timestamping, administration of multiple signatures. We have several protocols for the moment, Besu and Hyperledger Besu and Hyperledger Fabric, and some tools to integrate across different ledgers. We have some blockchain monitoring tools for each of the protocols, the Besu Block Explorer, the Fabric Block Explorer, and some network statistics to check that everything is running smoothly. And off-chain storage. So I should precise there that as blockchain is immutable, you cannot store, it has been decided in order to be compliant with GDPR, that we cannot store any personal information on the ledger themselves. So we have off-chain storage, distributed storage shared by all the nodes, but also private storage or external storage APIs, allowing to access off-chain, different kinds of off-chain storage. And the proofs of existence, of timestamping, of conformity to whatever smart contract, these proofs are stored on blockchain ledgers. So the data themselves are stored off-chain, and the proofs are stored in the blockchain. So how can you use the EBSI core services to build some cross-border service, for example? And the focus will be on identity and the diploma use cases. So quickly, the goal is to allow citizens to manage their identity, diploma, to register documents. So the citizens want to set up self-managed, self-sovereign identity digital wallet. A student wants to apply for a degree and manage their credentials, educational credentials. A young professional wants to apply to a job and also manage their credentials. An entrepreneur wants to create a company, applying to funding, and so you need to register and trace documents. You have the details. This presentation can be found on the EBSI website, and you can read the details. I don't have time to go into all the details, but let's see in a schematic way what can be done. So the first interaction is between the issuer and the user. So a government or a university applies, issues a credential, which is requested by a citizen using its wallet. And the evidences, the proofs are stored, the proof of the evidence of issuance, which is basically a cryptographic hash of the document, and the timestamping, which are done using the EBSI services. The document itself is in the wallet of the citizen. Then this citizen may want to show this wallet to a verifier, be it another university for to applying to a higher degree, or a company to apply for a job. And then the user on its control can show his data to, or her data to the verifier, which can check the proofs on the blockchain. So the interaction needs to happen via an EBSI compliant wallet. Okay, I will skip the details. And so now how you can build application using the core services. So if you issue a diploma, so the user, it's a business app, the wallet initiates the request for the issuance of this or her bachelor diploma, and then ask that to the university, here in the example, the University of Ghent, So the business app, the wallet, asks the wallet library, so the services of EBSI. There is the ID authentication API that enter into play, the verifiable credential, the ID hub, verifiable presentation are all used to build the request to the university. Then the university receives this request and sends issues the diploma to the requiring citizen, and writes on the registries the proof of issuance. And then this diploma is accepted by the citizen. So this slide explains how this can get into play in an international context. So the citizen is at the center of everything. The personal data store, the information is stored in the personal wallet of the citizen. And you have different governments into play for the identity verification, identity credentials. The different university, if you study in different universities in your during your life, you can interact with several universities, and you can a later university can check that your previous diploma has been correctly issued before by another university, and then you can interact with a different company, and all this the two main services used in this kind of interactions are identity services, the yellow dots, and the diploma services, which are the green dots here. And the ledger is the anchor of the trust between all these entities, citizens, universities, companies, governments. So EBSI is ready for you. We have several tests right now. We are building all this infrastructure. So the production ledger is appearing right now. Several countries are experimenting this use case. I am doing that in my university of Lille. We host the French contribution to EBSI, especially on this use case. So we build the node with Retour. Retour is the French National Research and Education Network operator, is hosting the French node for the moment. And we are working with an edtech company, BC Diploma, or Blockchain Certified Data, which with their solution BC Diploma, to issue digital verifiable diplomas to our students. So in the next days, we will issue the first digital diplomas to all our students from this year and last year. So it's 20,000 students per year in the University of Lille. For the moment, not yet on EBSI. We will use another blockchain, but we hope to be able to do that as soon as the process is completely validated in EBSI. And we're building it, so we build it so that it's validated. So maybe next year or the year after, the diplomas of the University of Lille will be issued on EBSI. So thank you for listening to me, and I'm ready to answer your questions.
Thank you very much, Pierre, for this very interesting discussion and presentation of the project. So perhaps I'll see if there is anyone in the room first, if someone wants to ask a question, and then we can move to the people who are online.
Yes.
François Verdier.
Yes. Thank you, Pierre. It was very interesting. But I have a question that is on the performance of the blockchain. Because we have tested a lot of blockchains in our labs, and the performance are very varied among all these blockchains. And I heard that you were talking about Hyperledger Besu. Is it right?
Yeah.
And what is the performance of this consensus blockchain with the inevitably the proof of authority consensus? Yes, what are the performance obtained by your blockchain?
So I don't have concrete numbers for you, but proof of authority is quite fast. It's much faster than proof of work for one, but proof of work is one of the slowest, so it's not difficult. And there is only a relatively small number of nodes, around 30 or 40 nodes right now. So the consensus itself is not, so it's fast enough for the first applications. It may not be fast enough for other applications involving IoTs, where you want to track lots of individual elements. So definitely it's not fast enough for this kind of applications. For diplomas, it's okay because you don't issue diplomas at such a rate that Besu cannot follow. But in the European Blockchain Partnership, we have opened a call last year to prepare for the future and for much more efficient or scalable algorithms. So the selection is ongoing of the different proposals. So it will be using typically second layer blockchains to enable scaling up. And we are in the process of building this new different, faster and more with more throughput blockchains in the infrastructure later. So for the moment, it's enough for the first use cases, which are not very heavy. But we're preparing the future with different research groups and companies which have answered a call for interest.
Okay. Thank you very much.
Thank you. Is there any questions maybe in the room? Okay, online.
Yes, I have a question for
Christine.
Pierre. I would like to know what motivates the choice to use a centralized database to start the diploma. Another solution may have been to keep the management of the diploma by the owner.
That is the case.
So the students.
That is the case. The diplomas themselves are stored in the wallets of the diplomees. They are not stored on the blockchain or on a centralized database. When they are issued, they are under the control of the citizen. So there is no central storage of the diplomas anywhere.
Okay.
We may want to store some let's say, presentation information. Presently with BC Diploma, these information are stored either on the blockchain themselves, and the diplomas may be stored on the blockchain themselves in the BC Diploma application. It will not be the case with EBSI. And you can use also distributed or decentralized storage systems like IPFS, for example, for storing this kind of application. But there is nowhere a centralized database.
Okay, thank you.
Thank you. Any questions in the room? Yes, there is one. I'm just going to bring the micro.
Okay, so my question is Okay, so it's about the smart contracts. How does the client see, and can he preview the smart contract before executing it? And how is it actually happening for the client? For example, in the case of the diplomas, how is the smart contract? How do they see the smart contract? How do they execute it? Is there something specific for it, or is it native smart contracts, or how is it working?
I'm not completely sure of all the details, but the intent is that the smart contracts are hidden to the citizen, to the end user. So the end user does not see the smart contract. It's a simple application. I request my diploma, I receive it, and the smart contract ensures the work underway to ensure the trust of the system, the correct signature of everybody, and so on. So if you build an application, you have a smart contract API allowing you to use the smart contract. And as the code is completely open source, the developer of the application can check what the smart contract does, how it works, and so on. So it's the code is transparent, and you access them through APIs, public APIs. So the builder of the application can check what the smart contract does exactly, but the goal is to hide them to the user. The user may not even know that there is a blockchain under all this. It just need to know that there is a trusted decentralized infrastructure. The technical details are not needed for using it.
Okay, thank you.
So I have maybe one last question, because we still have a couple of minutes before François' presentation. In the next project, as you will see, there are some problems in terms of acceptability of the solution and appropriation by the end users. In the project you presented, all the parties, companies, universities, and countries, to me, have a very high interest to accept this solution. So my question is, can you see any possible challenges in the implementation and the diffusion of these technologies among, the different users? Or do you think there is none?
Oh, there are. And there are some challenges, some political challenges. You need to convince the governments that that decentralized solutions are useful for them. Traditionally, in states, governments want to control data, and it's legitimate. But when so each time we talk to people in the ministries, they think, okay, I'm not convinced by the need to have such a decentralized infrastructure. Centralized solutions under our control typically work already today. In particular with identity verification and so on. We can issue the certificate today, and it's possible. But when you talk international solutions, thus you cannot trust another country with the verification of the identity of your own citizens. So you need something which works for all countries together. And there, decentralized solutions operated by the different countries together is a concrete opportunity to build such decentralized applications. And so the universities themselves are interested, definitely. The citizens, not yet, but maybe. And the experimentation we have done last year, the citizens, our students found it that yes, it's a good idea to have an electronic diploma because you can add more information than on the paper, and it is much less prone to fraud than the paper itself, which you never show your beautiful diploma on a special paper, you just show photocopies of them or scans, and these scans are very easy to fake. So the fraud is very easy today with paper diplomas, and it will be much less easy with electronic diplomas stored in such an infrastructure. Other examples of use cases are exchanges of monetary information for taxes at the European level, notarization of documents, so having proof of existence and of a document which is conformed to has not been tampered with since it has been created. So this is also useful. There is a study about the apostille. Apostille, it's an old convention. It's the way to recognize contracts in one country which have been signed in one country in other countries. So you need to translate. There is 120 countries involved in this convention, and all this is paper-based today. And so there is a proof of concept on EBSI of a digital apostille, the e-apostille. For refugees, also, it's difficult in Europe to track refugees asking for asylum in one country. If they move from country to country, it's difficult for them to prove that they have asked for asylum in another European country and have the right to move freely between the different European countries. But how do you prove in France that you have asked for asylum in Italy or in Germany? This is complicated today, so this is another case. Another application, maybe the European social security number. How a French citizen can benefit from his or her social security rights in other European countries. Today it's complicated. It's bilateral agreements between the different countries. If there is such a shared infrastructure where you can prove your rights from your country in the other European countries, it will be much easier for everybody. If you need to go to a hospital, you will be able not to pay first and be reimbursed after, but just being taken in charge like you would be in your own country. This is for the moment the cases I remember, but there are 7 of them today. And the identity verification basically of each citizen in all the participating countries also is part. You can prove your identity, and you can prove, for example, the technology is there, it's ready, it's not implemented yet, to prove that you have 18 years old without showing your birth date, your birthplace, your name, but you'll be able to prove that you have the required age to enter a bar or whatever. So the digital identity can enable also showing less information, only the needed information. So this is something which will be supported and by EBSI. We are building the ESIF, the European Self-Sovereign Identity Framework inside the EBSI, which enables such digital identity, self-sovereign, so under the control of each citizen. You show what you need to show and what you want to show only.
Thank you very much, Pierre. I hope we'll be able to keep more informal exchanges after today. And sure. It was really nice to welcome you in this morning of presentation. So now I will give the floor to François Verdier, who I introduced at the beginning of the morning. And after François Verdier's presentation, and before welcoming Christine Hennebert, we'll have a 10 minutes break.